Okay, welcome back to Dr. Happy Vagina. This is an educational channel about women's health, and my name is Ida Bergman and I work as a urogynecologist in Sweden. And today we will speak about the bladder physiology. And it's important that you have the basic knowledge about normal anatomy and physiology, and this is why I always start with the basics. And when you look at this picture, you might think, oh, this looks very, very complex. But if you listen to the end of this video, you will get an aha experience, because it's actually not so difficult to understand. And I will take you through this step by step. Okay, so in this picture, we see that here we have the control center, the brain. And under the brain, we have the brain stem. And in the brain stem, we have an area called the pontine micturition center. And here is where everything about this is controlled. Okay, and here we have the kidneys up here producing urine. And the urine is passing down through the ureters into the bladder that stores this urine until the bladder is full enough to send signals that now, please, you have to empty me. And we empty out the urine through the urethra. And around the urethra, here this little red thing, is a small muscle, a circular muscle, that is called the urethral sphincter muscle. And outside of the urinary bladder, we have the big pelvic squeezing muscles, which are the levator ani muscles. And inside the bladder, we have a muscle called the detrusor muscle. And this muscle is in the wall of the bladder. And when the detrusor muscle contracts, we empty the bladder. And when the detrusor muscle relaxes, we can store urine and the urinary bladder can stretch and distend. Okay, and now we will speak how the nerves speak with this detrusor muscle. And we will first start to speak about this hypogastric nerve. And the hypogastric nerve comes from the middle of the spine and sends signals out from the control center, sends out to a receptor. And these small black boxes that I have, one black box here, one here, and one here, these are receptors. And what is a receptor? It's something that takes a signal from a nerve and refers the signal to the target organ. So here we have the hypogastric nerve giving signals, and this signal transmitters is called noradrenaline. And noradrenaline goes to this receptor, which is a beta-adrenergic receptor. We call it the B3 receptor. And when we send signals with the hypogastric nerves, with noradrenaline to the beta-adrenergic B3 receptor, it speaks with the detrusor muscle and say, you can relax. You should not squeeze out the urine. Okay, and this nerve is a sympathetic nerve. So we cannot control this nerve. We cannot voluntarily speak with this nerve. It's the body doing its own thing. And the sympathetic nervous system is active when we are active, when we are in stress, or when we are doing something concentrating, or we are scared, or we are active. Then this sympathetic nervous system is also active. So if you are doing something, maybe running, stressing, speaking, then you don't even think about your bladder. And sometimes it's even if you are in super big stress, you have anxiety, you are super stressed, it's so active that sometimes it can be even difficult to empty the bladder because you are not in the relaxed state. You are so much noradrenaline in your body speaking with the B3 receptor, telling the detrusor muscle you cannot contract. So sometimes it's overshooting and we are blocking the urinary reflex. Okay, and then we have another nerve comes more from the lower part of the spine, and this is called the pelvic nerve, and this is a parasympathetic nerve when we are more calm and not in stress. And this nerve sends out transmitter substance called acetylcholine. And it speaks with the receptor, and the name of the receptor is muscarine receptor, M3. So remember this word, muscarine receptors, because in the videos later on we will speak about antimuscarine treatment. So muscarine receptors, try to remember this word. So when the pelvic nerve sends acetylcholine to the muscarine receptor, it's speaking with the detrusor muscle and telling the detrusor muscle, now it's time to pee. Okay, and then we have a nerve that goes out, speaking with this muscle, the urethral sphincter muscle. It also sends acetylcholine to the nicotine receptor in this muscle. And this is a voluntary nerve. So when we are, for example, in the elevator and our pee bladder says, I want to go to the toilet and urinate now, but we cannot, we don't have a toilet there. Then we can actively, voluntarily send signals to the nicotine receptor for the urethral sphincter and also to the levator ani muscle that we squeeze, we will not let the urine come out. So we voluntarily squeeze with these muscles. Okay, and then we need a nerve that's figuring out what's going on inside the bladder. And this is the sensory nerve. So it's feeling here with its nerves, how much pee do we have in the bladder now? Should we tell the brain to go to the toilet, or can we chill on that part? Okay, so when we have only a little urine in the urinary bladder, here we don't have so much, here, then this sensory nerve will send slow impulses, very, very slow impulses. It's not very active, it's slow. And these slow impulses, when they reach the spine, the spinal cord, it will speak to the hypogastric nerve that you can be active, you can send noradrenaline to the B3 receptor, telling the detrusor muscle it can stretch and relax. Okay, so we have slow impulses activating the hypogastric nerve and blocking the pelvic nerve. But then time goes by, we drink coffee, we drink tea, we drink Coca-Cola or something else, and the bladder will get distended with more fluid inside. Then this sensory nerve feels, oh, now we have to start speaking with the other nerve. We will send fast impulses, more quick impulses to this spine. And this will block the hypogastric nerve and it will increase the pelvic nerve. So it will speak to the hypogastric nerve, blocking it and telling the pelvic nerve to be more active so that the detrusor muscle can empty the bladder. So this is the basic physiology. And now you understand that if we have a problem with the nervous system, for example, MS disease, Parkinson, diabetes, neuropathy, or maybe we have an injury, spinal cord injury, then we might have a problem with all this complex speaking with the detrusor muscle. And sometimes because of changes that happens because of aging, we might have problems in the nerve endings in the bladder, in the detrusor muscle, in the sensory nerve, making these signals dysfunctional. Maybe we start to develop an overactive bladder that says that it should go and pee only when there is little urine. And we will speak about this more in the episodes that are coming. So stay tuned and remember to subscribe, and please, if you have a question, leave a comment. I love to discuss this with you, and I'll see you next week. Have an amazing day and amazing life.